Hey everyone, and welcome to another deep dive. Today, we're going to be taking a look at this research paper you sent in about making AI more efficient.
Yeah.
The title is a little intimidating, LoRA. Low-rank adaptation of large language models. But believe me, the idea itself is way cooler than the jargon.
What we're really talking about here is a potential breakthrough in how we train and use large language models.
Yeah.
The kind of AI that powers, things like ChatGPT.
Exactly. Now, I think most of us have at least played around with AI like ChatGPT,
Yeah.
and it can seem almost magical, right? Like how it can just generate text and answer questions, even write code. But what's maybe less obvious is the massive amount of computing power that's going on behind the scenes. We're talking about models with billions, even hundreds of billions of settings, or parameters, as they're called more technically.
Yeah. And that's where things get a little tricky. Let's say you want to fine-tune one of these AI giants for a specific task, like writing amazing marketing copy or translating languages flawlessly. Traditionally, that meant tweaking potentially billions of these parameters, which was insanely expensive, and it took forever.
Okay, so it's like having this super powerful computer brain, but then actually trying to personalize it for your needs was like trying to rewire a whole power grid or something.
That's a great analogy.
Yeah.
It's inefficient,
That's
to say the least. So researchers have been trying to find workarounds, smarter ways to adapt these massive models without, the massive overhead. Two common approaches that they've tried are adapters and prompt engineering.
So adapters, prompt engineering, I feel like we're already getting into the AI jargon. Can you break those down a little bit?
Sure. So imagine trying to make a giant one-size-fits-all sweater fit you perfectly.
Okay.
You try to add extra pieces of fabric, right?
Yeah.
So that's kind of what adapters do. They're like add-ons for the AI, but they can slow it down, which isn't really ideal. We live in a fast-paced world.
Especially for us learners, right? Like we want to get things done. We want it to be quick. We want it to be efficient.
Right. And then prompt engineering is basically like giving the AI very, very specific instructions to try to get it to give you the output that you want. And it has its uses, but it'd be really tricky and it has its limitations.
So it sounds like we're kind of stuck between a rock and hard place. We've got these amazingly powerful AI models, but actually using them efficiently for specific tasks is a major challenge. That's where this LoRa paper comes in, right? It's promising like a more elegant solution.
Precisely. The core idea behind LoRA, and this is what makes it so clever, is that instead of trying to change all the settings in a massive AI model, what if we could just pinpoint the few key tweaks needed for a new task?
It's like finding a shortcut. And who doesn't love a good shortcut, especially when it comes to learning?
Yeah.
But how does LoRa actually find those shortcuts?
This is where things get really, really interesting. So instead of making changes across the entire model, LoRA focuses on specific parts called attention mechanisms.
Attention mechanisms. Okay, now I'm intrigued. Tell me more.
Think of them like the AI's way of focusing. Just like, we pay attention to the most important parts of the conversation. These mechanisms are helping the AI kind of hone in on the key information it needs to process.
Okay, so it's like the AI has its own little spotlight, and LoRa figures out where to shine that spotlight for each task.
Exactly. And here's the real kicker. LoRa makes these adjustments in a way that's incredibly compact. It's like, condensing a whole textbook's worth of information into a few, key bullet points. The research team found that this approach, which they call low-rank adaptation, works surprisingly well, even with extremely large models.
Hold on, extremely large. How large are we talking?
They even tested it on GPT-3 175B, which is one of the biggest, baddest language models out there. And the results were remarkable.
Okay, you got to give me the details here. How did LoRa stack up against the traditional, resource-heavy methods?
They found that LoRa could achieve the same level of performance as full fine-tuning, sometimes even better, but with a fraction of the computational cost.
Right.
We're talking about making these massive AIs significantly more practical and accessible. But it gets even more interesting.
Wait, did you say a fraction of the how much more efficient are we talking?
Think of it like this. They were able to shrink the number of parameters LoRA needed to train by a factor of 10,000.
Wow.
That's going from needing a whole supercomputer to just needing your laptop.
Yeah.
It's a massive difference in terms of resources and accessibility.
Wow, that's a game changer. So Laura basically found a way to like make these giant AI models work like a Swiss Army knife. Like powerful, versatile, but compact.
Exactly.
Yeah.
But it's not just about making things smaller,
Mhm.
right? It's about making them smarter. Remember those attention mechanisms we were talking about?
Yeah, the AI's little internal spotlight.
That's right. What the research team discovered is that LoRa is actually figuring out which of those attention mechanisms matter most for a given task.
So it's like instead of like fiddling with every single dial on this like complex machine, it knows exactly which ones to adjust to get like the outcome you want.
Precisely. And what's even more fascinating is they found these adjustments can be incredibly simple, even with what they call very low-rank models, which essentially is measuring the complexity of the tweaks LoRa makes. They saw amazing results. They were able to achieve, performance on par with traditional fine-tuning, even when using a rank of just 1 or 2.
That's wild. It's like the researchers are saying that these massive AI models are actually much simpler than we thought. Like Laura is showing us we can adapt these complex systems with surprisingly small tweaks.
Exactly. It's like finding a hidden simplicity within these, seemingly impenetrable systems. And that's what makes this research so exciting.
So you're saying that even the most complex AI models have this like hidden elegance and we just need to learn how to unlock it.
That's a great way to put it. And that's what's so powerful about LoRa. It's not just about making AI more efficient for researchers in a lab. It's about making it more accessible and useful for everyone.
Okay, so I'm starting to see the potential here. What kind of like real world applications could we see with LoRa?
Imagine AI assistants that are faster, more personalized, and tailored to your specific needs. Imagine AI-powered tools that are, more affordable, less resource intensive. It opens up a whole new world of possibilities for innovation and creativity.
Okay, so I'm picturing AI tutors that actually understand my learning style and adjust to it like on the fly,
Yeah.
or AI powered writing tools that can help me, craft better content even if I'm not a professional writer.
Those are great examples.
Hmm.
And LoRa could have a huge impact on fields like healthcare, finance, and education, where AI has the potential to make a real difference, but it's been held back by the limitations of these, traditional fine-tuning methods.
Yeah.
This is about making AI more impactful.
You know what? It's like this research is giving us a whole new perspective on the potential of AI. Like if Laura can unlock this level of efficiency, who knows what other like hidden efficiencies are out there just waiting to be discovered. It's even making me think about the way we approach problems in our own lives. Maybe we're all overcomplicating things and there are simpler, more elegant solutions waiting to be found.
That's a great question to consider. This research is a reminder that true innovation often lies in finding those elegant, efficient solutions that make the seemingly impossible possible.
And that's what makes these deep dives so rewarding. It's not just about understanding like the technical details of a research paper. It's about expanding our perspective and embracing the possibilities of a future that's, shaped by increasingly intelligent and accessible AI. It really feels like we've uncovered this like treasure map for the future of AI,
Yeah.
with Laura showing us how to navigate the terrain and unlock the potential of these massive language models. Exciting time to be a learner.
Yeah, and the best part is that, this efficiency that we're seeing with LoRa, it's not limited to just a few specific tasks or data sets. The researchers found it works incredibly well across like a huge variety of natural language processing challenges. We're talking about everything from summarizing complex documents to translating languages, even generating, different creative text formats, poems, codes, scripts, you name it. LoRa can handle it.
So it's like having this master key that can unlock all this AI capability, but you don't need a supercomputer to turn the lock.
Exactly.
This has huge implications for making AI accessible to everyone, not just, the big players with the massive computing power.
Absolutely. LoRa could empower, smaller companies, startups, even individuals to harness the power of large language models without, that huge barrier to entry. And this opens up so many possibilities for personalized AI applications. Think like custom tailored chatbots, AI-powered learning tools, even creative tools that can adapt to your unique style and your needs.
This is where things get really exciting for me. Imagine a world where you have an AI assistant that not only understands your requests, but can can actually learn how you learn best and adjust its approach accordingly. It'd be like having this personalized tutor or coach available 24/7.
And the applications, they extend way beyond just, personal use too, right?
Yeah.
LoRA has the potential to revolutionize industries, right? Like healthcare,
Yeah.
finance,
Right.
education, places where AI can make a real difference, but its application has been limited by these resource constraints that we've been talking about. We can see more accurate medical diagnoses, more personalized financial advice, and learning experiences that are, truly tailored to individual needs and learning styles.
This whole deep dive has been really eye-opening. It's incredible to think that just by making these AI models more efficient, we're not just making them like faster or cheaper to run, we're unlocking, this whole other level of potential and impact. What started as a deep dive into, a research paper has really like, I don't know, it's expanded my perspective on the future of AI.
It really highlights the power of innovative thinking, right? By challenging assumptions and looking for, those truly elegant solutions, we can unlock possibilities that were previously unimaginable.
Well said. If LaLaurie teaches us anything, it's that there's always more to learn, and often the most impactful solutions are those that, combine power with elegance. So to all you learners out there, keep those minds curious and remember, sometimes the most complex systems hold within them the seeds of surprising simplicity. Until next time, keep exploring and keep those deep dives coming.